Univariable data, constructing and comparing data, created by Arnav Kanodia, Paul de Barros, Raymond Song, and Brandon Shen. Univariate data is a term used to describe a one-variable dataset. It is often used and very common on questions in AP statistics and especially on the AP exam. In this presentation, we will show you the ways to represent univariate data through dot plots, stem plots, histograms, and cumulative frequency plots. We will also be discussing about analyzing these representations of data. In a dot plot, each value is shown above its location on a number line. We always use a number line that includes all the data. It is very important when comparing data to use comparative language such as greater than or less than. When doing a comparison of dot plots, we want to compare the center, which is the median or the mean, the spread, which is the standard deviation or interquartile range. We want to check for outliers on both plots and see the shape of both of the plots. In this dot plot, we can see the mean of the control is greater than the mean of the treatment. We can also see that control is skewed left while treatment is about symmetric. We can see there are no obvious outliers, and the standard deviation of control is less than that of the treatment.
Stem plot's another way to organize univariate data. So as seen by the topmost picture, you take all the first digits of your observations and organize them into the stem column, least 0, and in this case 6, the largest first digit value. Then all the consecutive digits that come after the first digits you put as the leaves. So you always need a key, and 6-3 means 63 years old, where 6 is the stem and 3 is the leaf. So if you go to any stem value, suppose 3, then the 0 would represent 30, 3-0. And another type of stem and leaf plot is a back-to-back stem plot, the right picture, where you have one stem column and the leaves represent the different observations of the two different categories. So, and you observe it in the same way as a general stem and leaf plot. Finally, you have a splitting stem, where each stem, you can write it multiple times, but it represents a different set of observations, where, as you can see, one 3 represents 30 to 35, and the other 3 represents 36 to 39. And you always want to make sure you use a mean or median in the center and use standard deviation to describe the variability of the data. And you want to compare, if you're using back-to-back, compare both sides of the data. Attached is a practice problem on the next slide.
Okay, so now let's go into histograms. So how you create a histogram is first you divide the data into classes of equal width. And after that, you're able to plot how much of the data is in each class using a y-axis for the frequency or the relative frequency of the data in each class, and an x-axis for the separation of each class. So how you actually plot the data is you create bars showing the frequency for each of the classes, similar to a bar chart. However, unlike the bar chart, the bars are right next to each other, and this is for quantitative data. So after you plot the data, you can see the shape, whether it's symmetric or skewed, or unimodal or bimodal, and then you can see the center, which is usually the mean or the median, and you can also check for outliers.
Now we are going to talk about a cumulative frequency plot. A cumulative frequency plot is a method of displaying cumulative information graphically by showing the proportion, percentage, or number of observations which are less than or equal to a specific value. The cumulative frequency, as seen on the y-axis of the graphical display on the bottom right, is commonly mistaken with frequency. Cumulative frequency is the number of observations up to and including a specific data point, while frequency is the number of observations in that specific data point or interval. Cumulative frequency plots can either have frequency counts that are absolute or relative frequencies. Therefore, these plots can either have absolute numbers or relative numbers, such as the percentage frequency seen on the graph below. These graphs can have two types of data, discrete or continuous. Discrete data can take particular values, while continuous data is not restricted to definite separate values and can occupy any value in a continuous range. When addressing problems regarding the IQR and the median for a specific cumulative frequency plot, there are a few tricks to solving these effectively and correctly. Because the IQR makes up 75% of the data, the quartiles are easy to determine with a plot that uses relative frequency or proportions. Using the cumulative percentages, you can use the 25%, 50%, and 75% as the first, second, and third quartiles by using the graph.